Okay, so this is our continuing reading of Individuation in the Light of Notions of Form and Information. We're just towards the end of part 1 of the book on physical individuation, chapter 3. I forget which subsection, but we're starting at the top of page 153 of the translation. So we're still in quantum physics mode, and this subsection that we just started on last time is specifically about the double solution theory of quantum mechanics. So if you remember, this was the theory that Louis de Broglie proposed and then abandoned and then went back to in the 50s. And it's characterized by the positing of two separate solutions to the wave function. So there's the psi wave, which corresponds to the probability distribution in standard interpretations of quantum physics. And then there's the U wave, which is a nonlinear solution to the wave function, which would have the particles as singular region specks of reality on this interpretation. So they both have physical significance. There's a real wave, a real physical wave, and not just a wave in probability, like in the standard interpretation. And so we're going to look at, I guess, the ontological consequences of this theory in this section. So we just started it last time. The beginning of the section sets out the contrast between the probabilistic or indeterministic interpretation of quantum physics and the double solution theory, which is a deterministic one. And Simondon has argued, this is the last bit we saw, he has argued that the indeterministic interpretation of quantum physics has a conception of the individual, which is a substantialist conception. So it still posits physical individuals like particles as being sort of self-contained substances, and it's the reason it ends up with this sort of epistemological dead end where we can only have knowledge of probabilities and we don't actually have a true knowledge of reality. The reason for that is because that notion of the physical individual is an impoverished one. And so Simondon argues that with the double solution theory, we can have a conception of the individual as always being relative to a potential or something that is not individual. So the individual is always accompanied by something not individual. And so this is the sort of lesson he wants to draw from the double solution theory. Okay, so let's get into today's reading from page 153. I'll start, I think this is another long paragraph. Louis de Broglie argues that this realism requires a return to the Cartesian representations of space and time, where everything is formed by figure and movement. Several reservations should be made about this point. Descartes indeed refuses to consider action at a distance to be possible, and he only acknowledges action through contact. An individual must be present in a point in order for it to act there. The Cartesian representation of individuation precisely identifies the individual with its geometrical limits, characterized by its figure. On the contrary, it seems that the conception which considers the individual as the singularity of a wave and which consequently requires a field does not accept the Cartesian representation of individuation, even if it accepts its conception of determinism. To recall Bachelard's expression, there is a non-Cartesian epistemology, not in the sense of determinism or indeterminism, but in the sense of what concerns the mode of action of one individual on another, whether through contact or the intermediary of a field, what Bachelard calls electrism. However, it would actually be because probabilistic physics begins by way of an initial Cartesian definition of individuation that it culminates in indeterminism. And this initial definition of individuation forms the basic postulate of every physical theory. For Descartes, relation is not considered as part of the individual, does not express the individual, and does not transform the individual. Relation is accidental with respect to substance. The indeterministic theory conserves this definition of the individual, at least implicitly, because this theory calculates the probabilities of presence at a specific point without accounting for the individual that must be present there. This same theory of indeterminism is nothing but a determinism that postulates that hidden parameters do not exist. But what is precisely identical in this determinism and indeterminism is determination, which is always an event for the individual and not a relational operation. For both, determination is a rapport and not a relation, a veritable relational act. This is why we are better off not affirming too much the possibility of a return to the Cartesian conception of space and time. As Louis de Broglie has said many times, Einstein's system is much better suited to this conception of individuation than any other, including that of Descartes. A corpuscle that can be represented as a singularity of a field is not conceivable in Cartesian geometrism, insofar as a singularity cannot be introduced into this space qua res extensa, extended substance, without excessively modifying Cartesian geometry and mechanics. So here we have this idea introduced by de Broglie that we have to return to a Cartesian conception of what physics does and what physical explanations do, which would be in terms of figure and movement. So everything is supposed to be explained through figure and movement. And Simondon argues that this conception is not a good interpretation of the double solution theory, or not a good way of drawing the ontological lessons from the double solution theory. It's because in Descartes' physics, the individual is not related or isn't subject to a relation in the strong ontological sense that Simondon uses the term. So that an individual can have a rapport with another individual, but that's always something like an accident. It doesn't affect the substance of that individual in itself. The notion of substance is precisely defined as having to do with the self-subsistence or the isolated nature of that entity. So under the Cartesian conception, there's no role for relation as having the status of being. And so Simondon is arguing that it's precisely this conception of the individual as substance that lies behind the indeterministic theory or the probabilistic interpretation of quantum physics. So if we want to overcome that indeterminism like de Broglie does, then we can't rely on this Cartesian conception of the individual, and so we need a different conception of space and time and what physical explanation consists in. Right, so I think we can go on to the next page if someone else would like to read.
I can read. In the end, we could ask ourselves whether or not, instead of being capable of entering into the framework of an indeterministic physics or that of deterministic physics, we should consider the theory of singularities as the foundation for a new representation of the real that encompasses these two as particular cases, and that should be called the theory of transductive time or the theory of phases of being. This definition of a new manner of thinking becoming, which calls for determinism and indeterminism as borderline cases, applies to other domains of reality than that of elementary corpuscles. This is why we have been able to obtain the diffraction of bundles of molecules by crystalline surfaces. Stern, in 1932, obtained the diffraction of molecular rays of hydrogen and helium by verifying Louis de Broglie's relation between the speed and the wavelength, lambda equals h over m v, I think that's v in that new, within a margin of 1%. However, it seems difficult to generalize this method by applying it to all orders of magnitude without carrying out a recasting of what could be called the topology and chronology of the physical axiomatic, i.e., without rethinking each time the problem of the individuation of the ensemble in which the phenomenon develops. In this sense, two questions can be posed. What are the limits of the usage of the notion of the photon as a physical individual? What can we consider as the real source of light in the cases where the continuous wave characteristic of light is involved in producing a phenomenon? In these two cases, it seems that the physical system must be considered in its totality. Let's suppose that a magnetic field, for example, exists and is constant. We can speak of the field's existence and measure its intensity at a determined point, just as we can define its direction. Let's now suppose that what produced this field, for example, a current in a solenoid, stops. A solenoid, I guess, is just a magnetic coil that produces an electromagnetic field. The field will also stop, not abruptly and simultaneously in all points, but according to a perturbation that extends starting from the field's origin, the solenoid, with the speed of an electromagnetic wave. Can we consider this propagating perturbation as a photon, or at the very least as a grain of energy? If it were a question of an alternating magnetic field, this point of view would be normal. And it would be possible to define a frequency and a wavelength characterizing the presence of this alternating magnetic field. Would it not then be necessary to characterize the presence of the magnetic field, which is continuous in each point, as a potential that is a relation between the solenoid and the bodies capable of transforming these variations of the magnetic field in a current, for example? Then it could be supposed that the solenoid would disappear at the moment when the current that upholds the continuous magnetic field is cut. This perturbation would not propagate any less, as though the solenoid still existed, and it will be able to produce the same effects of induction in other bodies. Here, this will no longer be a relation between physical individuals, since one of them will have disappeared the moment when the perturbation will arrive in a determined point far from its origin.
So another interesting sort of like electromagnetic example of this is with radio antennas. Long story short, like the length of a radio antenna determines the frequency that it's able to receive. But modern antennas use a really powerful electrical charge spinning around the antenna as an electromagnet, which either lengthens or shortens the antenna's actual electromagnetic signature, so that short antennas can become longer to receive different frequencies outside of what their normal physical limitations would allow them to.
So the sort of big picture that he's developing here is this new conception of physical reality that he calls the transductive theory, a theory of transductive time, or the theory of phases of being. And this is what he's sort of hinted at in the introduction and a few other places, the notion of a pre-individual being that undergoes a phase shift, but we'll see more on how he develops that notion as we go along. And then he raises two problems or two questions regarding the individuality of a photon, or whether or not we should regard a photon as a physical individual. And so the first question is, he just sets it out as what are the limits of the usage of the notion of the photon as a physical individual. But the concern is that certain physical phenomena do suggest something like a photon concept, like we saw with the photoelectric effect. But there are other physical phenomena where it becomes much harder to posit a photon as the source of this phenomenon, and that's what he's starting with is that first problem, and then the second problem is has to do with the relation between the source of light and the receptor of light, or the object that is illuminated by that light beam. And so he's going to argue that we have to understand that we have to understand this as a real relationship between the source of light, or a real relation, I should say, between the source of light and the object illuminated, rather than just some sort of external rapport. We have to understand light as a real physical relation between the source of the light and the object illuminated. But we'll see more on that as we go along. And so the first question about the nature of the photon. So the the idea here is that, or the example that he's introducing is a sort of almost like a negative photon, you could say. So you have this magnetic field being produced by the solenoid, and then if the solenoid stops or even disappears, the magnetic field it disappears, but not all at once. The stopping of the magnetic field propagates outwards from the solenoid that has stopped or disappeared at the speed of an electromagnetic wave or the speed of light. So it takes a certain amount of time for that stopping of the field to propagate from its origin outwards to the limits of the field, and so this example shows that this propagation of the stopping of the fields is in one sense is a sort of negative photon, because we have this entity that's propagating at the speed of light. But at the same time, we can't regard this as a real physical relation in the case where, for example, the solenoid disappears, because one of the terms of the relation doesn't exist anymore. What this shows is that in general, we shouldn't regard this cutting of the field as an instance of a real physical individuation or a real physical relation. So that's the sort of purpose of this example, and he goes on to develop further forms in the next bit. Okay, so let's go on. If someone else would like to read the next page or so.
In the same way, it seems quite difficult to give the individuality of the photon to the modifications of an unspecified electromagnetic field. From 10-kilometer radioelectric waves, international and submarine telegraphy, to the most penetrating gamma rays, a formulaic analogy and a veritable continuity in both the modes of production and the physical properties tie together all electromagnetic relations. However, the granular nature of these radiations is quite apparent for short wavelengths, but it becomes extremely unclear for large wavelengths, and if we wanted, this could tend toward an infinite wavelength corresponding to a null frequency, without thereby nullifying the reality of the electrical field and the magnetic field. A perturbation that would be produced in these fields would propagate at the speed of light, but if no perturbation were produced, then nothing would propagate, and yet fields continue to exist, since they can be measured as continuous fields. Should the continuous field be distinguished from the perturbation that could propagate if it appears, the continuity of the field in each point can also be interpreted as an information, indicating that the source still existed at a determined instant. Since the field is real, it would be necessary to suppose as real an infinite wavelength that would correspond to this null frequency. But then the individuality of the grain of energy loses its signification outside the physical length, or the physical beings that radiate or receive this energy. Therefore, it still seems that a definition of physical individuality is to be specified. Perhaps we shouldn't speak of the individuality of the particle of energy like the individuality of the particle of matter. There is a source of the photon and of the electromagnetic perturbation. The conception of space would be contested. It is doubtful that the Cartesian conception can be suitable without being completed. Let us ultimately note that a quantitative formalism does not suffice to resolve this difficulty of relation between space and time. The cessation of a magnetic field is not identical to the establishment of a magnetic field. Even if the effects of induction that the two variations of flux can provoke in a circuit, both at the end and at the start, are equal, but for the current sense, the presence of the constant magnetic field corresponds to a possibility of energy exchange between, for example, the solenoid that creates it and a circuit that is made to turn at a certain distance in such a way as to penetrate one of its sides with a constantly variable flux. When the field no longer exists, this possibility of energetic coupling no longer exists. The regime of the possible energy exchanges in the system has changed. it can be said that the system's topology has changed due to the disappearance of a constant field that nevertheless did not transport energy when no flux variation took place. Thus appears the reality of relations other than those of events between individuals, such as the theory of probabilities can make them seem. Finally, it would be quite important to know whether the new path down which Louis de how do you say his name? Sorry.
De Broglie, basically.
Broglie? Louis de Broglie wants to see wave mechanics tread, suppress, or conserves the indiscernibility of individuals with the same characteristics, for example, electrons. Still using probabilistic methods, according to Kahan and Kowal, we must postulate that the probability of finding two electrons in two defined states when they are in interaction is independent from their numbering. This indiscernibility of identical particles disrupts the exchange in the problem that seeks their respective energy levels. We would also wonder if Pauli's principle of exclusion is still valid.
There was one point of translation that I think is a bit of an issue. So it's right at the bottom or near the bottom of 155. The sentence begins, "Let us ultimately note," but it's a long sentence, a couple lines down. So he says, "Even if the effects of induction that the two variations of flux can provoke in a circuit, both at the end and at the start, are equal but for the current sense." That bit, "but for the current sense," should be "but for the direction of current." That makes more sense based on what the French says. So the idea here is that if you have a magnetic field that begins or ends, it will produce a current in the electrical circuit, but the direction of that current will be the opposite depending on whether it's the field beginning or ending. So this paragraph, he has introduced the argument that he has already mentioned previously or already formulated previously, namely that the photon concept applies more specifically or it has a better application in the case of short wavelength electromagnetic radiation, so gamma rays or X-rays, for example. But in the case of long wavelength, like radio waves, it has a less clear application, and so he points out that you can increase the wavelength indefinitely. So in the limit, you would have an infinite wavelength or a zero frequency, and so this would correspond to no propagation happening in the electromagnetic field, but there's still a physical reality of that electromagnetic field, even though there's no propagation happening, because you have this potential for propagation of an effect from the source of the electromagnetic field. So there's this coupling between the source of the field and the other bodies that are affected by the field. So even if there's no propagation, there's still that coupling between them, and so this shows the physical reality of a relation, which is not something actual. It's a potential, but it's still real. So this is in connection with the second problem that he has introduced earlier about the relationship between the light source or the source of electromagnetic radiation and the body that is illuminated by that radiation. We have to go below the level of the actual relation and look at the potential relation or the relationship at the level of the field, which is a potential concept and has this coupling nature. And then in that last paragraph, he brings up the indiscernibility of particles having the same states in quantum physics. So sort of the short version of this is that if you have a system with, say, 2 electrons, and those electrons are in the same states, then you get the same results whether you count like one electron as the first one and the other one as the second, or if you invert the order. So there's no physical difference between the 2 electrons. Even though the system, there's a physical reality to the fact that there are 2 electrons, there doesn't seem to be any sort of physical reality to the order of the electrons. So which one is first and which one's second, you get the same results either way. And so there's a sort of indiscernibility of these particles because they have the same physical states, and there's no physical reality to the distinction between them, aside from the fact that they're the pure numerical distinction, the fact that there are 2 of them. But there's no physical properties that allow us to distinguish them from each other. And so this, Simondon is raising this as a sort of problem for De Broglie's notion of, or his understanding of wave mechanics and quantum physics in general. So he's just posing it as a question here, but the question is whether De Broglie's account of quantum physics will have the same indiscernibility effect, or is part of the deterministic account of quantum physics something that would give individuality or discernibility to individual electrons. And so it's just raised as a question, but I'm not sure if he answers this later on. I don't think so. Okay, so we can go on to the next page or so. I'll start reading. A similar difficulty relative to the individuation of physical systems appears in the phenomenon of interferences. Whenever we consider an experiment of interferences in the non-localized field, we theorize this experiment, Young's slits, contemplated as a means of producing not a diffraction but 2 synchronous oscillators, Fresnel's mirror, Bier's lens, by saying that the light waves are emitted by 2 synchronous sources, which are synchronous because they receive their light from a single source, and that they are themselves nothing but secondary sources arranged at equal distances from a primary source. Yet if we carefully consider the structure and activity of this primary source, we realize that it is possible to obtain a very clear phenomenon of interference, with extinction practically complete in the dark bands, even if a primary source containing a very large number of atoms is used. A source, for example, constituted by a segment of tungsten filament 0.5 millimeters long and 0.2 millimeters in diameter, necessarily contains several tens of thousands of atoms. Furthermore, we can take an extremely voluminous source, like a carbon arc lamp, in which light emanates from a gap and from a point whose active surface, from which the column of luminous vapor stems, is about a square centimeter for a strong intensity. However, since it has passed through a minuscule diaphragm that serves as the primary source, the light that emanates from this strong luminous area is capable of producing the phenomenon of interference as if it were produced by a very small segment of incandescent filament. Then is there a real synchronization between the molecules and the atoms of these large luminous surfaces? Every moment a very large number of non-synchronized oscillators emit light. It would seem normal to consider the phenomenon as a result that conforms with the law of statistics. You would then have to suppose that the phenomenon of interference will be all the more unclear because there will be a greater number of non-synchronized oscillators. We mean by this not oscillators at different frequencies, but relative to an unspecified phase, in order to constitute the primary source. And it does not seem that experimentation verifies this prediction. Yet, given the order of magnitude of the sources utilized, even the smallest sources already contain a large number of elementary oscillators that do not seem to be able to be in phase. These oscillators cannot be in phase when they have different frequencies. However, the phenomenon is always produced even though only the central bands are distinct, since the bands relative to each frequency are less superposed the farther they are from the central band. What is the phase synchronization that can exist between waves emitted by oscillators of the same frequency? Does this synchronization arise from the unity of the system that contained them? Is there a coupling that is produced between these oscillators placed at a short distance from one another? But if a primary source is constituted by means of an optical apparatus that unifies the rays emitted by 2 distinct sources, would this phase synchronization remain? or instead is the phenomenon independent of any phase synchronization. It is perhaps noteworthy to link the study of light to that of the source which produces it. The photon's individuality cannot be considered absolutely independent from the oscillator that produces it or from the system from which this oscillator possibly belongs. Thus, all the oscillators included in the same energetic system would have a certain linkage between them that could make synchronization possible, and there would be not just a frequency synchronization, but a phase synchronization between these oscillators in such a way that the individuality of the photons is affected and somehow marked by this original systematic community. Finally, let's note that the light originating from a star can still give rise to a phenomenon of interference, as if the source were actually that of an extremely small real diameter. It nevertheless seems impossible to consider a star as a single oscillator, even if it presents itself with an apparent diameter smaller than any assignable magnitude. The extreme smallness of this apparent diameter cannot in principle change the phase rapport of the different photons picked up by the interferometer. Photons that originate from parts quite distant from one another relative to wavelength on the star that is taken as their source can be picked up by this interferometer. Then where does this synchronization come from? It no doubt comes from the apparatus in which the interferences are produced, but the latter is not itself a veritable source. Or instead, it is necessary to suppose that each photon is divided into two quantities of energy that would be like semi-photons, and that each half of the photon would manage to interfere with the other half on the screen in which the phenomenon is produced. This supposition hardly appears acceptable precisely due to the individual nature of the photon. For all these reasons, it seems that we cannot bestow physical individuality upon the photon in the sense of a material corpuscle. The photon's individuality would merely be proportionate to its frequency, i.e. to the quantity of energy h nu that it transports, without this individuality ever being able to be complete, since it would then require this frequency to be infinite, and no oscillator can produce an infinite frequency. A photon that would have an infinite frequency could be assimilated to a veritable particle of matter. We should still note that there perhaps exists a threshold beyond which it could be said that the photon's frequency corresponds to a veritable individuality. This frequency would be that for which the photon's energy is or would be equal to the energy of a material particle, whose transformation into energy would precisely give the quantity of energy that would be the energy of this very high frequency photon. This photon would then be functionally equivalent to a piece of matter. Yeah, Angus, I think you're right that the core of this passage is the idea or the thesis that we can't grant physical individuality to the photon to the same degree as we can a material corpuscle like an electron or a proton and so on. So we can only regard photons as having a degree of individuation or individuality, which is relative to their frequency, and then we would conceive true physical individuality as the limit of an infinite frequency, which of course is not physically possible. But yeah, so this is in a sense the sort of culmination of this whole part of the book, because he's introduced this question earlier of whether we can regard a photon as a physical individual, and so now he's finally answering in the negative. So photons are not physical individuals. So some of the arguments that he introduces here have to do with interference experiments. So the interference in a double slit experiment is when you have a light source that shines through the two slits in a screen, and then appears on the back wall of the experimental apparatus. There's a set of dark bands that appear where the light coming from the two slits interferes with each other, so that you get these dark bands. And so he, in this long paragraph, what he introduces is the question of what happens when you have two different sources of light. In theory, or a priori, you would expect that the interference phenomena would only be produced, you'd only see these dark bands if the light waves are synchronized with, if the light emitted from the two sources, the waves are synchronized, so they have the same frequency and the same phase. So if you shine a light through one slit and another light through the other slit, they should only produce interference bands under the rare circumstance when the light emitted from each source is synchronized. But that's not what you find in empirical experimentation. So you can use a source, a light source that has a surface of several centimeters, and so it has tens of thousands or millions of individual particles that are emitting photons, and so in theory or a priori you would expect that their distribution of the phase would be basically random. So there would be no synchronization, but at the same time, we find that we still get these interference phenomena, even using light sources like that have a surface a surface diameter of several centimeters. And he even points out we even can produce interference using light from a distant star. So the star appears as a point source in the sky, and you can use that light to produce interference phenomena. But of course, at the source itself, the star is millions of kilometers in diameter. It's a huge entity relative to the wavelength of the light that's emitted. And so we would again expect that the phase of the light would be distributed at random, and so we would expect that it wouldn't produce this interference phenomenon, but in fact it does. And so Simondon, he doesn't really explain how this effect should be understood as coming about, but he raises a series of questions and suggests that it's the experimental apparatus itself that produces something like the synchronization or the apparent synchronization. So the interference effect is a result of the experimental apparatus, rather than some sort of synchronization of the sources. So for this reason, we can't really consider the photon to be a physical individual. We have to understand the photon's individuality as relative to a system of interaction, rather than as something that is sort of inherently self-sustaining.
So maybe I missed some parts, but then in terms of photon, then you think like that is not the some inherent like latent kind of pre-individuality, but the some kind of external factor which influences possible transformation, something like that. Or you think like that has to do with some kind of that idea of the seed or the crystal of the crystallization or something like that? I'm trying to understand like this part, like just like by keeping thinking of the part like pre-individually, like kind of like do the things like keep like interaction with the external factors, surroundings or environment, whatever. So what I'm thinking regarding photon and the oscillator, and also I'm wondering like what's the exactly like oscillators are, and then what kind of energy? I mean, where energy oscillators the movement comes from. Something like that. Maybe it sounds really basic and ignorant. Sorry about that. But if you have any possible answers, it will be very helpful. Thank you.
Yeah. I don't know if I can answer all of those questions, but so the idea, so an oscillator is just a source of well, in this case, a source of electromagnetic radiation. So electromagnetic radiation has a wave form, which is produced by an oscillator, so something that has some sort of alternation. You can picture it as like an up and down movement or a rotation or something like that. So it has a periodic change which is propagated through the electromagnetic field in the form of a wave. And so the so the reason why we want to consider light sources as oscillators is because there's so the light wave has the same periodic structure. It has like when you consider light as a wave, you can picture it as similar to a wave in water. It has a crest and a trough. So that analogy is not 100% accurate because light waves are transversal waves, not longitudinal waves. But in general, the idea is that an oscillator is something that has a periodic change. It can be a rotation or an increase and decrease in some sort of physical quantity. And then that periodic structure or that periodic change is transmitted or propagated through electromagnetic waves. And so the question here that Simondon is bringing up is whether we should regard those oscillators as having some sort of real relation to the target or the entity that is illuminated by this electromagnetic radiation. It's a little bit complicated, the argument that he sets out, and he also sort of doesn't fill in all the details of the argument. He gives some parts as questions, but the idea is that because we can produce these interference phenomena, so these dark bands on the wall, we can produce them using light sources that couldn't possibly be synchronized with each other in terms of frequency and phase. Like, for instance, the light from a distant star. So because we can produce these interference phenomena in these circumstances, it shows that the interference phenomena are not that we shouldn't understand the interference phenomena as being as having to do with a real relation with the source, and instead we should understand them as being produced through by means of the instrumental apparatus in some way. He doesn't really specify what that would look like, but it's the two slits or the setup of the experiment is what produces the interference rather than a real relation with the source. And so because of this, we shouldn't think of the photon as being a real physical individual, but we should regard photons as having some sort of relative individuality, so proportionate to the frequency of the light beam or the electromagnetic radiation, rather than having an intrinsic individuality.
Yeah, thank you. So actually, like my kind of like a continuing question has to do with some kind of the origin of energy, like it might be to do with some kind of agency. Like I'm not sure, like if like the discussion agency like is proper here. But the thing is that what Simonian is trying to is like to explain in terms of physics. He's trying to like what happens is what happens, things like that. Or there could be some voluntary energy agency of an individual, like that kind of thing exists, or something just happens like dies of through. Like in nature, there is something we can't, as a human being, like handle. So Simone is just trying to make us understood in terms of physics. Is that like kind of just complicated like explanations? He just trying to explanation what it's called like a phenomenon, like in terms of individuation, like in terms of physics. Is it the right way to understand this, Paul?
Yeah, I think if I understand correctly, I think that's right. So, how I would put it is that he wants to develop ontological concepts, or more generally philosophical concepts that are adequate to some of the results of empirical sciences, and so he wants to have a mode of thinking that is capable of thinking physical reality, rather than being sort of excluded from physical reality, or being only able to think measurements or appearances or something like that. So he wants to have a real access to physical reality, but in order to do that, we have to draw from empirical sciences and make our concepts adequate to those sciences, rather than sort of imposing presuppositions on those sciences. I'm not sure if that answers exactly your question, but that's sort of how I see what Simondon is doing here.
Thank you. Like it's enough like to make think twice. And then if I have more questions, I will do it later. Thank you so much.
Yeah, feel free to ask questions as we go along. So I think we can go on to the next section, or subsection, I should say. And this one is a little less physics intensive. It's more ontology related, I guess you could say. So if someone else would like to read, you can take it away.
4. Topology, chronology, and order of magnitude of physical individuation. Furthermore, if we contemplate microphysical reality directly, an interpretation of individuation starting from the phenomena of structural change would aim to consider becoming as essentially linked to the operations of individuation that are carried out in successive transformations. Determinism would remain applicable as a borderline case when the system considered is not the theater of any individuation, i.e., when no exchange takes place between energy and structure, which would modify the system's structures, thus leaving it topologically identical to what it was in its previous states. On the contrary, indeterminism would seem like a borderline case when a complete structural change manifests in a system with the transition from one order of magnitude to another. This is the case, for example, of the modifications brought to a system by the fission of an atomic nucleus. Intranuclear energies, which up to that point belong to the internal system of this nucleus, are unleashed by fission and can act as a gamma photon or a neutron on the bodies that belong to a system situated on a scale larger than that of the atomic nucleus. Nothing in a macroscopic system allows us to predict at which moment of macroscopic time there will be a fission unleashing an energy that will nevertheless be effective on the macroscopic level. Indeterminism is not merely linked to measurement. It also stems from the fact that physical reality involves topologically interlocking scales of magnitude, each of which has their own becoming and their own particular chronology. Indeterminism would exist in a pure state if there were no correlation between the topology and the chronology of physical systems. This absence of correlation is never absolutely complete. This can only be said abstractly of an absolute indeterminism, realizable by a complete internal resonance, or of an absolute determinism, realizable by a complete independence between chronology and topology. The general case is that of a certain level of correlation between a system's chronology and topology, a level which is moreover variable due to the vicissitudes of its own becoming. A system reacts on itself not only in the sense of the principle of entropy through the general law of its internal energetic transformations, but also by modifying its own structure through time. The becoming of a system is the manner in which it individuates, i.e., essentially the manner in which it is conditioned according to the different structures and successive operations through which it reverberates within itself and phase shifts relative to its initial state. Determinism and indeterminism are merely borderline cases, because there is a becoming of systems. This becoming is the becoming of their individuation. There is a reactivity of systems with respect to themselves. The evolution of a system would be determined if there were no internal resonance of the system, i.e., no exchange between the different scales that it encompasses and constitutes. No quantum structural change would be possible, and we could know the becoming of the system in a theory of the continuous or according to the law of large numbers, as thermodynamics does. Pure indeterminism would correspond to such an elevated internal resonance that any modification occurring on a determined scale would immediately reverberate throughout all levels as a structural change. In fact, the general case is that of quantum thresholds of resonance. In order for a modification produced on one of the levels to reach the other levels, it must be above a certain value. Internal resonance only develops discontinuously and with a certain delay from one scale to another. The individuated physical being is not totally simultaneous relative to itself. Its topology and chronology are separated by a certain gap that is variable according to the becoming of the individuated whole. Substance would be a physical individual, totally resonant with respect to itself, and consequently totally identical to itself, perfectly coherent with itself and singular. The physical being must be considered, on the contrary, as more than unity and more than identity, rich in potentials. The individual is undergoing individuation based on a pre-individual reality that sustains it. The perfect individual, totally individuated, substantial, deprived, and emptied of its potentials, is an abstraction. The individual is undergoing ontogenetic becoming. It has, with respect to itself, a relative coherence, a relative unity, and a relative identity. The physical individual must be thought as a chronotopological whole, whose complex becoming involves successive crises of individuation. The being's becoming consists in this non-coincidence of chronology and topology. The individuation of a physical ensemble would then be constituted by the interlinking of the successive regimes of this ensemble.
So we have here the reintroduction of the notion of orders of magnitude, which we saw a fair bit in the earlier chapter on crystallization and so on, but has not really played a big role in this notion of orders of magnitude. We saw earlier, and then it didn't really play a big role in the rest of this chapter, but then now he's bringing it back in. So the example that he uses now in this case is nuclear fission. So you have in fission, you have a transition from one state in which the nuclear energy, the intranuclear energy, is sort of bound up within the microscopic scale, and then you have a transition to a state in which that energy is released at a macroscopic scale. And so again, this is a difference of order of magnitude, and he characterizes the difference between determinism and indeterminism as sort of two limit states with respect to the degree of resonance is the term he uses, but you could say correlation between the orders of magnitude within an entity. Pure determinism would be a state of an entity in which there were no, or to put it another way, in which the orders of magnitude would be perfectly correlated with each other. So there would be nothing like this sudden transition like nuclear fission, where a microscopic energy is released at a macroscopic scale. Everything would be determined in the sense that there would be no unpredictable events like nuclear fission. And then the other limit is pure indeterminism, which would be a state where there would be no correlation between the different orders of magnitude. So it would be as if nuclear fission type phenomena were the only phenomena that existed. Everything would be happening just sort of at random. But then in reality, what we find is not either of these two limit conditions, but rather a mixed condition where you have a degree, a relative correlation between, as he puts it, between the chronology and the topology of the system. So between the evolution of the system through time and the structure of the system in terms of orders of magnitude. So there's some degree of correlation between the different orders of magnitude, but they're not purely they're not absolutely correlated with each other or completely correlated with each other, and so you get threshold effects like in the case of nuclear fission, where you have if a certain quantity is higher than a certain threshold, then you end up with a transition, a discrete transition in state of another property, and so this is the general situation with physical individuation. So most physical individuals or physical individuals in general have only this relative correlation with themselves or resonance, internal resonance with themselves, rather than an absolute correlation with themselves, which is what a substance would have.
So it seems like he's associating the idea of chronology here with the idea of these different thresholds between different phases of individuation. Is that right?
I think the chronology here is, I was going to say no, but I think actually you might be right. So the chronology is, no, I'm not sure. The way I understood it at first is that the chronology had to do with the evolution of the system through time. So over time, the system has a set of states which varies with time. And then the topology would refer to the structure of the system in terms of the orders of magnitude. But I'm not actually sure now if that's the correct interpretation.
Yeah, that was my question, because he uses the non-coincidence of chronology and topology when he's at the end of the paragraph, when he's saying the physical individual must be thought of as a chronotopological whole, blah, blah, blah. The beings becoming consistent is non-coincident chronology and topology. But interestingly, that's also how he describes absolute determinism, if I'm not mistaken, above, when he's saying, sorry if I can find it, at the top of 159, absolute determinism realizable by complete independence between chronology and topology. So I don't know if there's a way in which it's sort of like in terms of them both being limit states, determinism and indeterminism being two borderline cases within the evolution of a system, I suppose. I'm not sure. Like, is it that is he identifying the becoming with a kind of determinism in the sense of what we've talked about before, not a determinism in the classical sense, but of like, that once a seed or a singularity begins, like some process is activated and it begins some process of individuation, it's happening in a direction, or there's a directionality to it. But that basically what I took as the non-coincidence thing was that in order for that to happen, there's the whole thing from way at the beginning of the book, another text where he talks about in pre-individual reality, it's like sort of pre-chronological, it's a traditional notion of time, and that like we've talked with all these different examples of things all of a sudden unfolding all at once, once the potentials are activated, and individual reality starts to get made or starts becoming, I guess. Like, I guess I'm mixing a bunch of these things, but the way I thought of it in my head was the reason there's a non-coincidence of chronology and topology is because from the beginning, there's a topology, like for example, in the example of the crystal with a supersaturated liquid, and then the chronology sort of it's not coincident with the topology itself, because then you would just have kind of a classical notion of being or substance, right? So once it's introduced, it's almost like afterwards or in a second step, if that makes sense, or after the phase shift, then you can start to have becoming. I don't know if any of that makes sense, to be honest. This is just where I was thinking.
Actually, I had a similar question. It's like in terms of spatial temporally, like, because like when I read like another book about Simondon, like I remember that like the individuation process, psychic and collective process, it was kind of defined as a processual. Like, so the part that like I'm wondering also is like, is it like a mixture of the idea of a coexistence and the processual process altogether? And then what I focused on here is like a chronology. I mean, chronos. Like I don't know why. Like I just extended my idea to the chronos versus the ion, and Simondon's idea, like as a scientist, maybe he in a way like was stuck to some kind of linear process of time and space, something like that. So kind of wondering too.
Maybe I'll answer that last point first. So there's a distinction between chronos and ion that Deleuze makes in Logic of Sense, where he argues for these two distinct orders of time. I would have to admit that I don't remember in a lot of detail what the distinction between those two orders of time is. If I remember correctly, ion has to do with the event, and then chronos is something like the constituted individual time. I think Simondon doesn't really have a notion of the event in the same way that Deleuze does. I think there's no event concept in Simondon, and so there would be no ion concept of time, in strictly speaking. But I think Simondon does have this distinction between time and becoming, because as we saw in the introduction, he brings up the idea, or he asserts in the introduction. We don't really see the argument for it there, but he asserts that time itself is something that has become. Time is a result of a process of becoming, and so it's that becoming can't be strictly identified with time. It's something that is outside time in some sense, or is prior to time in a logical sense. So I don't think we could say that Simondon has a strictly linear account of time, because he wants to account for the genesis of time, or a becoming of time, and so that notion of becoming is more fundamental than time as a linear sequence of moments or something like that. On the other point that Alyosha brought up, I think so that there's that bit right towards the end of the paragraph where he says the being's becoming consists in this non-coincidence of chronology and topology, and then we can connect this or compare this with what he says a page earlier on 159, where he says indeterminism would exist in a pure state if there were no correlation between the topology and the chronology of physical systems. My understanding here is that the second one, the one on 160, the statement on 160, when he says non-coincidence of chronology and topology, he's talking about the relative non-coincidence. So the relative coherence, relative unity, relative identity, the partial correlation between orders of magnitude that make up an individual. And so this, we have to distinguish this non-coincidence, or this relative coincidence, with from the complete absence, the no correlation between topology and chronology, which is what would characterize indeterminism. that's how I understand the passage, but it could be stated a little more clearly, I think. But yeah, I think that's a way to make sense of what he's talking about. At least, no, I think it's determinism is that determinism is the complete internal resonance, if I'm not mistaken. Oh, yeah, that's weird. Let me just take a look at the French to see if that's what he says there.
See, that's kind of what I was getting at, is that I think you're right that something in the way I explained it doesn't make sense. But the thing that is confusing there is saying an absolute indeterminism realizable by a complete internal resonance versus absolute determinism realizable by complete independence between chronology and topology. So I may take your point if it bears out that maybe non-coincidence is not quite the same as in total independence, although it seems to me like they're both, it's like saying perpendicular, that those are two different ways of saying that. But yeah, the internal resonance thing, because that seems to call back to even earlier in the text as well, with other example, the more physical examples that we talked about with the brick and other things like that. So I'm trying to reconcile those things, I guess.
Yeah, I'm just trying to look quickly at the French to see whether it sort of disambiguates this, because it looks like the English text, the one that you posted in the chat there, has it backwards, as far as I understand it. But I'll have to check if that's correct. Yeah, so it looks like the French text actually does have the same as what the English does. Yeah, so this absence of correlation is never absolutely complete. It is only abstractly that we can speak of an absolute indeterminism realizable by a complete internal resonance, or of an absolute determinism realizable by a complete independence between chronology and topology. Yeah, that sounds like he's put it backwards there. I wonder if that could just be a mistake on his part, or it could be that I'm misunderstanding what the connection is between the determinism and internal resonance. Yeah, that does seem backwards. Yeah, that's interesting. I'm glad you brought that up, because it looks like he wrote it backwards there. So I think, my hypothesis would be that we should understand absolute indeterminism as a complete independence between chronology and topology, and absolute determinism as a complete internal resonance, rather than the way that it's written in the text. But yeah, that would be like a correction of the text, so intervening in the text itself rather than just interpretation.
Wait, so just to clarify, the idea is that indeterminism has no internal resonance and determinism has total internal resonance?
Yeah, that's right. That's how I understand it, which requires a amending the text in that one passage.
Can I just bring up an example? I know we have to move on, but from page 56, from page 28, this is where I had thought of with the clay example. And I'm just looking here. He says each point has as many chances as all the others. The matter about to take form is in a state of complete internal resonance. What occurs at one point reverberates within all the others. The becoming of each molecule reverberates within all the others at all points and in all directions. The matter's elements are neither isolated from one another nor heterogeneous relative to one another. All heterogeneity is a condition of the non-transmission of forces, and therefore a condition of internal non-resonance. The plasticity of the clay is its capacity to be in a state of internal resonance as soon as it is subjected to a pressure in an enclosure. The mold as a limit is that through which the state of an internal resonance is provoked, but the mold is not that through which the internal resonance is realized. It's what uniformly transmits in all directions the pressures and displacements from the within the malleable clay. I don't know if it completely clarifies, but that is the aspect that I feel like, because I remember getting caught up on this, because to me, internal resonance seems to indicate a kind of heterogeneity just intuitively. That's what you would think. like a kind of open system with a lot of different elements to allow something to happen. But there's, again, I don't know if this helps in some way, but to me, it always seemed like what he was trying to say is, in the example of he's saying heterogeneity is a condition of non-transmission of forces. Maybe it means different orders of magnitude, I'm not sure. But there's a way in which, in order for internal resonance to occur, there has to be a kind of, again, a topological homogeneity to at least that version of the system state or whatever, in order for things to be transmitted across it. So I think in that case, counterintuitively, you could maybe read indeterminism as precisely that like things can go in any direction precisely because there's like a surface or a continuity to it rather than a discontinuity. And that it's precisely when there's discontinuity, like in the case of corpuscles and other things, like we've even seen with the probability experiments and all these things that we've been talking about, that you start to get into the area of determinism because you're starting to sort of link so-called separate events through a chain of causality or something. Again, I don't know if this is too tangential, but I maybe we should put a pin in it and come back to it because it does seem pretty important to me to understanding what he's saying.
Yeah, I'd have to go back and look at that passage again. When he brings up the idea of homogeneity, he's talking about how the clay has to be homogeneous, like it can't contain any little pebbles or something like that, in order to transmit the forces in a uniform manner across itself, and produce a brick that won't have any cracks or flaws in it. And so that's what he characterizes as the state of internal resonance is that capacity to transmit the forces uniformly. And I would tend to align that with the determinism side of the opposition that he makes here in the part that we're reading. Yeah, I think it would be worth going into that more closely and trying to see what the relationship is between his use of the term resonance in this passage and in the previous one that you brought up. But yeah, so I think we can go on to the next bit and sort of keep this question in mind for the future. Let's see. Yeah, we have some time still. So I can read the next bit, page or so. So we're at the first full paragraph on 160. Such a conception would therefore consider energetic regimes and structural states as convertible with one another through an ensemble's becoming. Due to the notion of orders of magnitude and the notion of thresholds and exchanges, it would assert that individuation exists between the pure continuous and the pure discontinuous. The notion of thresholds and of quantum exchange is indeed a mediation between the pure continuous and the pure discontinuous. It would bring in the notion of information as a fundamental characteristic of individuation, conceived according to dimensions that are both chronological and topological. We could then speak of a more or less elevated level of individuation. An ensemble would possess a more elevated level of individuation in proportion to the greater amount of pre-individual reality it would envelop and compatibilize in its chronological and topological systematics, or in proportion to the difference between orders of magnitude. Such a hypothesis supposes that there is no elementary individual, no first individual anterior to every genesis. There is individuation in an ensemble. The first reality is pre-individual and is richer than the individual understood as the result of individuation. The pre-individual is the source of chronological and topological dimensionality. The oppositions between continuous and discontinuous, particle and energy, would thus express not so much the complementary aspects of the real as the dimensions that emerge in the real when it becomes individuated. Complementarity on the level of individuated reality would be the translation of the fact that individuation appears, on the one hand, as ontogenesis, and on the other hand, as an operation of a pre-individual reality that not only produces the individual, the model of a substance, but also produces the energy or the field associated with the individual. Only the associated field-individual pairing accounts for the level of pre-individual reality. This supposition of the first pre-individual nature of reality is moreover what allows us to consider the physical individual veritably as an ensemble. The individual corresponds to a certain dimensionality of the real, i.e. to an associated topology and chronology. The individual is an edifice in its most current form, i.e. in the form in which it appears to us, whether crystal or molecule. As such, it is not an absolute, but a reality that corresponds to a certain state of generally metastable equilibrium, and is founded on a regime of exchanges between the different orders of magnitude that can be modified either by internal becoming or by an external event that brings a certain new condition to the internal regime. For example, an energetic condition when the neutron originating from the fission of a nucleus provokes the fission of another nucleus. Thus, there is a certain consistency of the individual, but not an absolute antipathy, an impenetrability in a substantial sense. The consistency of the individual edifice is still founded on quantum conditions. It depends on thresholds. So, individuation has to be understood in relative terms. It's not an absolute all or nothing in the sense that there would be some individuals and then other entities that are not individuals in a strict sense. We have instead degrees of individuation, and so a system is individuated to the extent that it incorporates more of the pre-individual. So we have this pre-individual reality that undergoes a phase shift or a dephasing, and into separate orders of magnitude, and then we have the individuation process that sort of recaptures part of that pre-individual reality, but the individual is always accompanied by something non-individuated, and so it's only the total system, including both the individual and the non-individual field, that corresponds to the initial pre-individuated state. And then there's a question in the chat about whether, or a comment, I guess, about whether something of the meaning of individual doesn't get lost as soon as we begin to speak of relative individuation. Yeah, that's a good suggestion or comment to make, but I think what Simondon was trying to do is to transform the concept of individual in such a way that it has a greater capacity to think physical reality. So we want to, I guess, like we should expect that the notion of individuation that Simondon is using will be different than our sort of everyday notion of individuation, but based on the physical phenomena that he's been discussing in this chapter and then throughout this part of the book, he wants to make the case that that this is a superior concept of individuation compared to the sort of standard or everyday concept of an individual.
Well, another thought I had, again, I don't know if this is correct or not, but I just really like that the second to last paragraph we read, where he says where is it? The oppositions between continuous and discontinuous, etc., would express not so much the complementary aspects of the real as the dimensions that emerge in the real when it becomes individuated. Complementarity on the level of individuated reality would be the translation of the fact that individuation appears on the one hand as in ontogenesis, and on the other hand as an operation of pre-individual reality. And I just thought that was interesting because I think, at least for myself, and I'm very behind, so I apologize, but it's very easy to slip into the kind of, if somebody asks you for a summary of Simondon, to just kind of give this general account of, there's pre-individual reality and then there's ontogenesis and then everybody goes home happy. At least that's how I've tried to explain it. And there's something about what he's saying here which isn't necessarily new, but I just like that he's saying it's not simply that these are sort of like different aspects of the real, but they're actually sort of it's almost like if you look at everything through the lens of ontogenesis, that's helpful, and it works, and it obviously has a relationship with pre-individual reality. But he seems to be implying that if you're looking at it through the lens of ontogenesis, it's not exactly completely possible to then place yourself within the pre-individual reality. And if you do that, the latter, then it's hard to place yourself in the former, precisely because of I think what I was saying earlier of like in the pre-individual reality, it's like the field of potentials before individuation has happened, and ontogenesis is seemingly during or after, or when the process of individuation occurring. And yeah, I don't know. It's not like I don't have a specific where direction I'm going with this. I just thought it was interesting because I would have thought commonsensically that the first part is sort of the way I would explain it, is these are different aspects of the real. But it's like he's saying that's not enough, I guess, to just look at it that way. That, yeah, again, sorry for not having a better point, but I just thought that was very interesting.
The two aspects, or the two sides of that are the physical individual and the fields, or the non-individuated portion of reality that is associated with it, they always come together. You can't isolate one from the other. That's maybe a secondary sense in which the individuation is relative. So it's relative in the first sense, in that it's never complete individuation or absolute individuation. And then a second sense is that it's always relative to individuation of an individual is always relative to the non-individual that surrounds it in that field. And so that we can understand that as a second sense in which individuation is relative. I'm just looking at the time and the amount we have left, and I don't think we would have to rush to finish the subsection and the part of the book as a whole. So I would suggest we can end a little bit early today and keep the rest of the last bit of this subsection for next time. But if there are any objections, I'm open to alternatives. So yeah, let's end here for today, and we'll pick up at the top of 161 next time. We'll finish out the first part of the book, so we're like, I don't know, a third of the way through, maybe, or maybe closer to a quarter. I'm not sure exactly, but we're through the first part of the book next time. So that will be our transition into the world of living individuation, vital individuation.